And welcome to space. Welcome to the Smash News Network, least busted name in news, and welcome to the daily space weather. We've got a further decline in solar activity here since yesterday. We've got the SDO feed back on our HelioViewer videos, and we've got a likely coronal mass ejection headed Earth's way. We can expect significant geomagnetic storming from that. Perhaps the aurora becoming visible once again at mid-latitudes. These are the past approximately 24 hours there. There's a little bit of sinking problem happening at the beginning there between the SDO 211 plus 171 angstroms. And by the way, that coronal mass ejection came from the southwestern limb. Those are different wavelengths. That's 304 plus 193 angstroms. And we've got some massive filaments on the Earth-facing portion of the solar disk as well. The likelihood of coronal mass ejections continues to be nearly 100%. Again, that's the region where the CME came from. We'll show you some more information about that a little bit later in the video. Some other wavelengths for you there. Here's yesterday plus today in SDO intensity gram, and there is a sunspot down here that ought to get named. Besides that, we see a further decrease in solar activity and the sunspot number. There is your colorized magnetogram, and we do see some magnetic field organization happening down here. However, no sunspots yet so far. That is only a plage, not a sunspot. There's the full disk view in our fantastic SDO 304 plus 193 angstroms. And let's take a look at volcanoes. So if you're wondering what's erupting, so are we. Starting out the list with Shiveluch there on the Kamchatka Peninsula. So Shiveluch exploding, producing a 15,000-foot plume of volcanic ash. It's a flight level 150 over Kamchatka from Shiveluch, flight level 140 over Bezimiany, located in the central Kamchatka Depression. Bezimiany also exploding, 14,000-foot plume of volcanic ash over Bezimiany. Subanose Jima producing a 5,000-foot ash plume. Semaru exploding, flight level 140, 14,000-foot ash plume, 19,000-foot ash plume over central Mexico from Popocatépetl. Go ahead, say it aloud, I dare you. Popocatépetl. Also Fuego exploding, flight level 170 over Guatemala, 17,000-foot ash plume. Not sure about Nevado del Ruiz. Don't pole vault the caldera. It could be unhealthful. Sangay exploding mildly. In Ecuador, sporadic emissions of volcanic ash there, and Sabancaya continuous ash emissions, no indication of the ash plume size. Let's take a look at seismicity, but first, we invite you to check out our merch shop. If you haven't seen it before, one of our latest creations is Maxa, because, yeah, we're riffing on MAGA and so on. So, Maxa, and by the way, we have zero political party affiliation. I've never been associated with a political party and probably never will be. However, I am associated with cosmology. I almost majored in cosmology back in the mid-90s before, well, I think there was only one. I think it was only Caltech, or it might have been UCLA, that was offering stellar cosmology as a major. I would have had to do just like, I don't know, astronomy with a physics minor or something like that would have been fine, but didn't really want to move to California, and I didn't really want to create my own major. So anyway, I'm back, and the reason that I'm doing these deep dives into heliophysics is because one of our many goals is to make astronomy and cosmology science again. If you want to read more about our mission, head to smashomash.com/forum/mission. You can read all about our mission. It's got a lot of things, so don't be ossified in your beliefs. And if you want to support the channel, the official subscription services site is smashomash.com/smashteam. So make sure you join us over there if you haven't. There's even a bronze level over there where you can still get email alerts without paying us anything. So perhaps get those. We typically send out email alerts before the USGS even does. And now I'm going to shrink across the screen and get smaller and smaller and smaller and smaller, and now I'm really small. You can also find links on the Smash Team page to the Hemp Lucid shop. So check that out if you haven't. Enter the promo code SMASHOMASH to save some dough on your checkout. There are the most popular items, Links below the video as well as on the homepage at smashomash.com, and welcome to the Neo Renaissance, the official homepage of the Smash News Network. Least busted name in news, smashomash.com. Hit us up on Discord. You can always follow us on our Discord chat. There's a permanent invite link to our Discord channel right there, and we'll be using that in the future to allow viewers just like you to talk on our live streams in real time. It's a thing. It's coming back. Maybe even today. Who knows? Next, we're looking at global seismicity, and we've got a bit of a 7 magnitude earthquake drought. So that's a 90-day bar graph there for your convenient viewing pleasure. And only one barely 7 magnitude quake has occurred in the past, well, since early February. So a little bit of an earthquake drought, and a quick reminder, earthquake droughts end in large earthquakes. Now, over the past 24 hours, we didn't see any major quakes. We did see some in the Cascadia Fault Zone up here off the coast of Vancouver and off the coast of Oregon. Largest quake of the past 24, I believe, was this 5.1 in Iran. Looks like that one might have caused a little bit of damage. Also some quakes around California there. And a quick reminder that any earthquake can be a foreshock. I stand corrected. The largest quake of the past 24 was a 5.5 in the Flores Sea, north of Western Australia there, south of the Philippines. And let's get back to space. Here's a 24-hour video in 193 plus 171 angstroms from SDO. And again, the 10.7 centimeter radial flux has dipped once again all the way down to 125 solar flux units. There is the 1-year graph to put that in context for you. This black line is the radial flux. The red line below it is the sunspot number. The blue line is the AP index. That's earthly geomagnetism. And then you've got the 30-day Wolf number. That is the 30-day sunspot average. Let's take a look at the Space Weather Enthusiast dashboard. We do see a little uptick here. NOAA is nearly forecasting geomagnetic unrest there, 3.67. That's almost geomagnetic unrest conditions. Maybe they're trying to hedge their bets there by saying that the CME from yesterday isn't directed toward the Earth, but I would say we're going to see more like a KP7 on April 4th, maybe as high as even a KP8, as that coronal mass ejection appeared to be directly Earth-facing. So NOAA's not forecasting any geomagnetic storms here, although there was a little bit of a possibility of geomagnetic unrest this morning. And let's take a look at their Enlil spiral here just to see what's going on. To see where NOAA forecasted that CME from yesterday. So it looks like there is no model for that CME. I don't see anything happening. So no model there at all. And here's NASA's model. So this one has got the CME on the opposite side of the sun. And I guess this one will just have to be a point of contention until we get to late in the day on April 4th. So again, NOAA not really calling for any significant impacts. We're calling for a major impact, basically a direct hit late in the day on April 4th. So there's the forecast from NASA. You can see it's going the exact opposite direction. We've got it forecasted going in this direction. Actually, it's a little bit to the west. So a little bit to the west like this. Keep in mind, Earth is moving in that direction with respect to the solar system. So a complete opposite forecast there. NASA versus us. All right, so here's the last 4 hours of Earth's magnetic moment from space. Let me just bring that back. We've got an apparently very diffuse solar wind, but still at very high speeds. So we'll get to that in a minute. This is the last 4 hours of Earth's magnetic moment from space. It's depicting magnetohydrodynamic pressure, modeled by the Space Weather Modeling Framework. And we can expect to see this coronal hole high-speed stream sputter down. So I can expect to see variations in the solar wind speed over the coming 24 to 36 hours. Here's Earth's magnetic moment from the ground for the past 4 hours. The units here depicted are nanotesla magnetic flux density. And again, we are in geomagnetically calm conditions here despite the increased solar wind velocity. We'll let that play through since it refreshed to show you the most up-to-date information. And thanks for leaving a comment. Life Force Rejuvenation, who is hoping for boxcars, which I guess are better than snake eyes or something. Next, global geomagnetism, the KP index, the planetary K index, an average of global geomagnetism. KP3 is the current situation, again, geomagnetically calm conditions. And next we'll look at the real-time solar wind. So, basically what happens, folks, is when you have a coronal hole high-speed stream, you get this like spiral-like feature that comes out as this comes out and diffuses out into the greater solar system. And at the moment, we have one of those hitting the Earth. It's just very diffuse. So current conditions are solar wind velocity here still quite elevated here at 542 kilometers per second. Solar wind density really low here, barely 1 proton per cubic centimeter. And let's move on to the magnetic data. There are your GOES magnetometers first, the GOES 16 and GOES 18. And let's take a look at the heliospheric current sheet as there is a sector boundary crossing showing up pretty soon here in the next couple of days. We've got a North Pole current sheet on the way and a South Pole current sheet on the way out. So that's our top view ecliptic plane field plot. A very important piece of data there. And that's derived from 51 ground-based magnetometers. Magnetometers out here on stereo B and out here on stereo A. Here's our line of sight field plot. And we do have some North Pole-oriented coronal holes rotating in. So let's move to our coronal hole view. And there is our coronal hole view. Oh, thanks so much, John. Thanks for posting a TikTok link in the chat. Great idea. Great idea. So here's our line of sight coronal hole plot. We've got a bunch of South Pole-oriented coronal holes mostly, but we should have some more well-defined North Pole coronal holes rotating in here from the southeast. So let's take a look at that in 211 angstroms. So we should see these systems down here get a little bit more well-defined. Not very good view of those North Pole-oriented coronal holes yet. Again, if you look at the latest image there, you can see these are indeed North Pole. And there's also some North Pole magnetism still up here at the heliographic North Pole. Now let's move to sunspots next. And this group down here should have gotten a name already. That'll be 3268 will be the name of that new sunspot group. And let's take a look at some SDO videos. There's the SDO continuum plus 171 angstroms. We'll zoom in a little bit closer there to give you a little more detail. And let's drop the 171 angstroms to show you a nearly sunspotless disk. Compared to what we've had, that is a very low number of sunspots. So again, expecting a name for this sunspot down here. It's looking pretty weak, but it doesn't have a name yet. It's certainly been there for more than 12 hours. So it ought to get a name. It'll certainly get one today. We'll still see the sunspot number drop unless something suddenly happens. And let's move to energetic particles and flares. So solar flaring's been quite low, and we haven't had any spikes in the proton flux. So no solar energetic particle events here. There's the X-ray flux dropping off a cliff, along with the sunspot number and the radio flux. So a big lull in solar activity here. Here's the past 24 hours in SDO 94 plus 131 angstroms. There still is an outside chance of seeing some flaring from the northwest limb and from the southeast limb. Those are the most likely places to see flares. Keep an eye on this area and keep an eye on this area. Those are the places you can expect to see flares at the moment. We don't expect any large ones. We don't have any magnetically complex sunspot groups. And let's take a quick moment to see what's going on overhead. So we just had the Venus rise in the northeastern sky here over Lehigh Valley, PA. Of course, it's not visible because the sun's already up. And if you were looking at the night sky there just after sunset, you might see Jupiter, Mercury, and Venus there shortly after sunset. So Mercury pretty high in the sky there. Pretty bright here for the beginning of April, I believe. And if you're up before dawn, you might be seeing Saturn in the morning sky there, just to the south of the ecliptic. Here's our solar system view. We're going to show you a 1-week forecast, as Earth is lonely on a portion of the solar system with 0 planets, which I guess nobody's frightened of that. They're only frightened when the Earth is on a side that's populated with planets, even though it has just this side of nothing to do with anything resembling astrophysics. All right, so here is our 1-week forecast. Here's where things will be on April 9th. And let's look at coronagraphs. Since NASA thinks the CME is off in this direction, and we think the CME is off in this direction. Basically a 100% margin of error there between our forecast and NASA's. So right at the beginning of this, you're going to see a halo. I believe that's an Earth-directed coronal mass ejection for various reasons, and we're going to show you some of those reasons here. We also put out a video about it yesterday, so if you didn't see that, make sure you look at yesterday's videos at youtube.com/smashomash/videos. That'll show you our latest videos in order of release. Let's take a look at stereo A plus Soho Lasco C3. There you can see that halo happening on the stereo A as well. And unfortunately, since stereo A is so close to the Earth now, it's not helping us out very much with the trajectory of coronal mass ejections at all. So this is pretty much the worst case scenario that we hear as far as this is the worst case scenario here as far as being able to actually accurately guess the trajectory of a coronal mass ejection. And we'll just reiterate in a minute here why we think it's earthly directed and not on the far side. First, we're going to show you some 24-hour coronagraphs in excellent composite. By the way, there's also a huge filament down here. It's probably on the far side of the sun somewhat, but there is a huge filament down here and a huge one up here as well that you can see on the coronagraph. So let's take a look at filaments here. What the heck? Did I not put in coronagraphs? I apologize. Just give me a minute here. I'm going to throw my coronagraphs in here. I was so surprised that the SDO was back online that I must have forgotten to place the coronagraphs in the video tabs. All right, so here are our 24-hour coronagraphs. That's Jupiter in the imagery there. You can see it's moving at a very similar speed to the background stars. Here's a little closer view. And there's an even closer view. All right, so the filament situation is there are a lot of filaments and there are some massive ones. So a couple filaments here could use names, maybe 3 or 4 of them. So this filament could use a name, this one up here, also this one here, and this huge one down here could certainly use a name. So if you want to name filaments, make sure you join us over on Twitter. More on that in a minute. Likelihood of coronal mass ejections remains really high, nearly 100%. So just a quick reminder, folks, we don't need to see any solar flares or even sunspots to see coronal mass ejections. These things can sort of just spontaneously go blasting off. And we started making our videos just before the solar cycle 24 to 25 minimum transition. All right, let's zoom in here briefly. This is a great composite wavelength here. We're going to slow this down, bring this back. So this plasma right here, we don't really see this snapping back down. We see some of it splashing down here, but we see plasma that is clearly on this side of the corona. If this was on the opposite side of the corona, it would look a lot less detailed. So that little bit of plasma right there that you see, that's an indication that that CME is earthly directed. Usually when we see those on the opposite side of the sun, they have a tendency to be very blurry, as a lot of this coronal material would be in the way. Let's let that play through another time here. Pretty sure that's headed toward us. And yeah, so let us know in the comments if you disagree. We will not take it personally. It does not hurt our feelings. In fact, we enjoy being incorrect, especially if it leads to changes in our thinking, as we are attempting to advance the science in good faith. Heliophysics equals cosmology. And this is just an added bonus that we're giving our viewers. This is the data that I wanted to look at daily, so you're welcome. Here are the past couple of hours from the GOES 16 SUVI, and things remain calm somewhat. But again, lots of filaments there that could use names. And that brings us to our bonus features. And thanks for leaving a comment, Mr. Bordages. Let me just pause for station identification here. You've reached the Smash News Network, least busted name in news, and thanks for leaving a comment, Tin Man 1057 as well. Good morning to each of you, and thanks everybody who leaves comments on the videos. It really helps us with the algorithms. So we've got some charging hazards here for satellites, some significant surface charging over the Central Pacific Ocean at the moment. That's caused by low-energy electrons building up on the surfaces of satellites, hence the term surface charging hazards. The GOES electron flux here, expected by NOAA to rise. Not sure on that one. I would just tend to say, I'm just going to agree. I'm going to agree with NOAA's forecast. That's the past 3 days of radiographic measurements by the GOES 16 and GOES 18. There is the forecast model. NOAA expecting a little uptick here. So we'll go into warning territory here for the day today. According to NOAA's forecast, no arguments from me there. There's the 1-year graph to put the electron flux in context. It is measured at the F layer of the ionosphere, the bridge between Earth and space. And here's the vibrational frequency of that slice of the upper thermosphere, the F layer of the ionosphere. Again, it's located at about 300 kilometers of altitude. And it helps us to show the sort of relatively immediate effects of space weather on the Earth system. This is one of the places where we've documented repeatedly that you can see things happening. Let's take a look at the anomalygram as well. This is anomaly in megahertz from a 30-day median. So some significant low-frequency anomalies, especially happening around the South Atlantic anomaly and the Southern Atlantic Ocean. Also some around the North Pacific and Siberia and so on. Let's bring up the latest image. There it is, 1300 universal time ionogram. And there's 1300 universal time anomalygram. Will also show the total electron content. That's the free electrons between your GPS satellite and your handset. Keep in mind this imagery does show a forecast of a half an hour. It does attempt to forecast the electron content. We are seeing some significant anomalies here. Some electrons out of place there, although it is still fairly organized. Again, that's the likely location of free electrons from your GPS satellite all the way down 12,500 miles to your handset. Here is the anomaly over North America. That's electron content anomaly from the 10-day average. And we'll show North America by itself. There's just the U.S. basically. And let's end our space weather video with some high-res imagery. Again, this area down here, when we did show prep, it wasn't a sunspot. And it doesn't look like it's a sunspot now either. That's just a plage. Although this sunspot has gained some ombre, so that's always interesting. There could be a sunspot hiding back there somewhere, but at the moment, we've just got this group to get a name today, and that is now a Beta Gamma class sunspot group. You could maybe even say Beta Gamma Delta, but those ombre just formed, so that one should get a name. 3268, I believe we said would be the name of that one. Besides that, very low levels of solar activity. And we're almost at our meteorology segment. And before we do that, you are invited to press like, subscribe, share, etc. If you didn't see, we put out 2 extra videos yesterday on YouTube. So if you want to see the more in-depth analysis of the coronal mass ejection, check out Earth-directed CME, not an April Fool's Day joke, but fun nonetheless. And also, may that solar wind be at your back. That's our new channel video, our channel trailer, so to speak. So make sure you press like, subscribe, share, comment, etc. Thanks to everybody who's tolerated the disgusting, putrid, ridiculous censorship on YouTube. And thanks to everybody who's tolerated the disgusting, putrid, and ridiculous censorship on Twitter. Once again, don't forget to name that filament, which is a practice we'll only allow you to do on Twitter, because we're trying to get more people to use the platform, despite it being basically just ridiculous. But, I mean, we are approaching 400 followers, by the way, despite having over 19,500 tweets over 4+ years, daily original content, our own web ring, etc. Are you signed up for email alerts from smashomash.com/smashteam? Well, you can find the link in the profile to the Smash Team site, as well as to the YouTube page. And if you're viewing the videos on BitChute, for goodness sake, go subscribe over on YouTube. You're missing most of the content. And if you're only subscribed on YouTube, maybe go subscribe on BitChute, because you're missing the most ridiculous comments. All right. And keep in mind, folks, we are free speech purists. We encourage all legal speech. Just keep in mind, you may be berated if you say something ridiculously in the comments. So, yeah, we encourage all free speech. We're free speech purists at smashomash.com, not free speech phonies. Anyway, we're looking at the planet's lowest pressure. So this is mean sea level pressure right here. And it's just west of the Drake Passage, one of the weirdest places in the world, where the Atlantic and Pacific Ocean attempt to reach static equilibrium. You know, you've got a bunch of water that has to flow through this little inlet, the Drake Passage. And right now we've got a low pressure on the west side, which means water is likely rushing this way as the sea is bulging up right here. It's bulging up, folks, as there's less air pressure to push down on the ocean. That's what a storm surge is from a hurricane, by the way. It's not just the wind, it's also the ocean rising up. So that's the lowest pressure in the world. And is the highest pressure on the world down here at the South Pole? Well, 1,085 hectopascals. It's pretty high. Do we have any higher? 1,085 hectopascals. I think that is the highest and the lowest pressure zone there. Pretty close to each other at Antarctica. Anyway, that's mean sea level pressure, and the animation there is just winds, as those two things are related. Of course, we see the highest winds associated with low pressure, which is essentially a suction on the atmosphere, which seems like wind, but it's really suckage. Does your favorite YouTube channel suck golf balls through garden hoses? Does it suck tennis balls through drinking straws? We want to know, so let us know in the comments. Does your favorite YouTube channel absolutely suck at their own job? So here's our meteorology segment. This is surface wind scenario for the eastern world. That's what's going on over the. There's the jet stream scenario for the Eastern world. Shout out to our viewers from all around the planet. Who knew we'd make so many pals by putting out factual videos about things like space weather and Earth weather? Seems so easy, and believe me, it's not. All right, so there are the jet streams of the west. Here are the surface winds of the west. Strong winds in the Atlantic Ocean. Here are the surface winds of the central world. And last but not least, the jet streams. So that's what's going on. Let's take a look at clouds and fog over the Americas. Using our NASA GOES interactive weather satellite, the 3.9 nanometer shortwave radiation infrared map. It's super good. It can help you see where there are likely to be aurora able to be seen. Because at nighttime, your visible satellite won't work. But this one will. You'll be able to see if you have clear skies around sundown on April 4th, which is, by the way, Tuesday night. So here's our weather.gov map. We're going to scroll down to show you the key briefly. We've got a bunch of winter storm watches there in the north-central U.S. If your location is lit, head to weather.gov and click your location. That's a little bit too many weather alerts for us to cover. And let's take a look at some forecasts. So first is the temperature anomaly forecast. We've got some very warm air coming back to Lehigh Valley in the coming days. That's the GFS temperature anomaly forecast in degrees Celsius. And it's going to stay cold west of the Mississippi. Here is our pressure and precipitation forecast based on the same model. We've got some ice falling at the moment, some freezing rain in North Dakota. We'll get to it. 72-hour GFS pressure and precipitation forecast depicted here. And here is your 72-hour accumulated positive snow depth change in inches. Two more feet of snow coming to Wyoming. Also California. And there was a great Twitter share early this morning about snowpack in Utah. Yet another reason to follow us on Twitter. There's all kinds of exclusive content over there that you won't see anyplace else, hence the term exclusive content. So that's our 72-hour accumulated positive snow depth change in inches. It's the GFS model. And here's our current precipitation type. So you can see significant freezing rain happening there in North Dakota. That is suboptimal. And most of the precipitation in the country, besides in Florida, Louisiana, and a little Mississippi and Texas, is almost entirely snow. Some snow mix happening there in West Virginia, some snow mix happening in southern Minnesota, and some wet snow falling all around the Pacific Northwest. That's your precipitation type on windy.com. Windy.com, they got a great mobile app. It's free. Check it out. Here's our NASA GOES lightning mapper, and some heavy lightning there moving toward Bermuda at the moment. Let's see if we've got any real-time strikes on our real-time lightning map at lightningmaps.org. Yeah, lightningmaps.org. Good times. And we do indeed have some active cells out there in the western Atlantic. Some stormy seas there west of Bermuda. There's your full disk view. We've got some Italian lightning happening as well. And we'll close things out with Doppler. Clouds and fog and water vapor. So here's your full 50-state view. U.S. Doppler radar map. We'll focus on the lower 48 view. Here is clouds and fog. Again, the 3.9 nanometer infrared radiation map. It's still dark over half the country, so this works. And last but not least, the water vapor map. So interestingly here, we've got this like atmospheric creek happening right here. And you can see it's bumping into this high pressure zone, and that's helping to force it to the east. And then this is acting like a wall here, keeping it down in the south. So that's going to sort of continue there at the moment, unless it's able to break through this dry mass of air here in the middle. So that's something to keep an eye on. And that's something that weather forecasters can get wrong, by the way. It's pretty hard to calculate all the chaotic processes that happen. It involves things like how much sunlight is making it down there and evaporation, humidity, barometric pressure, temperature, all those sorts of features. Great example there of a blocking feature. So you've got all this. This is all effectively high pressure with respect to the more moist air around it. And even this little area right here is, relatively speaking, higher pressure, at least than the air to the south of it. So that's where we'll close things out. Here is your recap. U.S. Doppler radar. 3.9 nanometer infrared radiation, which shows clouds and fog. And the water vapor map. We're delighted that you've viewed the video. Thanks for tuning into the Smash News Network, least busted name in news, and thanks for stargazing with us. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Also, don't forget to visit the links over here and here and here.